Nastavljamo, kao što smo rekli, predavanjem Karoline Backman. Ona je specijalistkinja za cirkularni dizajn u 3XN-u Kopenhagen. Diplomirala je na Univerzitetu u Melbourneu, a magistarske studije završila na Tehničkom univerzitetu Delft. Kao što smo rekli, specijalistkinja je za cirkularni dizajn i ugljenik i istovremeno pruža strateške savjete klijentima o ciljevima održivosti ESG-a. Vjeruje u iterativni pristup dizajnu kako bi se osiguralo da se mjere za smanjenje ugljenika razmotre u svim fazama projektovanja i da se koriste digitalni alati za brzu analizu uticaja varijantnih rješenja. Koristi znanja o ponovnoj upotrebi i razmatra sva tri vitalna dijela smanjenja emisije ugljenika tokom životnog ciklusa zgrada. Radila je na projektima u Ujedinjenom Kraljevstvu, Danskoj, a također bila uključena u projekat Europske unije za kružne regenerativne gradove. Izvolite, please.
And thank you for having me in this beautiful city. It's really nice and it's fantastic to be here as part of this discussion on the very important topic of reuse. My name is Karolina Backman. I'm a circular design specialist, but also a schooled architect, and I work for GXN. GXN is an independent design-driven research studio. We focus on sustainability through both behavioral design research and also circular design research. We have been around for about 15 years. We were founded as part of an architecture company called 3XN, and then we have now spurred out in the last few years as an independent company. But we have a very close relationship with 3XN. So we sit under the same roof in this beautiful building in Copenhagen, and together with 3XN, we then explore how we can create unique solutions for very complex problems. We do this with our offices in Copenhagen, Stockholm, New York, Sydney, London, and Amsterdam, and we work on projects all over the world. What we have, which is very unique, is that we have a collaboration that allows us to do both research and then apply it in practice. So at GXN, we say that we are the geeks, we're the nerds. We do about 40% of our work as research, funded from lots of different institutions. And then about 60% of our work is as sustainability consultants on projects that 3XN is involved in or that other architecture practices are involved in. So we have this very close collaboration, and we're a very interdisciplinary team. So we work in this flow where we share ideas back and forth throughout all design stages. And we do this on lots of different scales. So both everything from master plan scales and urban planning down to very much material science. And one of the big areas that we have really been geeking into in the last 15 years is circular design. What this comes from is really that we're fascinated that when we construct buildings, we take so much care in actually putting them together, both in terms of the energy that goes in from whole design teams to actually design them, plan for how they're going to be constructed, to the very care that we put into actually putting them together. But when it comes to the end of life of buildings, we seem to take absolutely zero care. They just go into a pile and they become waste. And why is that we waste all of this value and energy that has gone into buildings? So we did a lot of research on this, and in 2016 we published a book that was called Building a Circular Future, that was looking into how we can actually change this and continue the value of the buildings that we put together. It outlines, it's still available, you can find it for free online. It's been updated in 2018. And it kind of outlines the basic principles of how we move towards a more circular future. And what we have done since then is looking into how we can apply that in practice. So what we really see is that what we're doing at the moment mainly is a linear construction that results in a lot of waste. We extract resources and create building materials like a brick, which should have a technical lifespan of about 200 years. There's brick buildings out there that has been around for much longer than that. But we put them into a building in, say, a facade. And a facade often needs to get replaced every 30, 50 years, which means that the technical lifespan of that brick gets linked to the lifespan of that facade, and suddenly becomes much shorter. At the end of the life of that building or that facade, we then throw that out, which means that we wasted 150 years of a functional lifespan of that brick. What we think we should be doing instead is really looking at how we can harvest resources from the existing environment, making sure that we make the most use of that technical lifespan that we have put in, and then also enable those resources to be harvested in the future as well. And we think this creates a circular construction economy where we have a constant flow of resources that can either be harvested from existing buildings that might need to change use or have come to the end of life, and then that we design buildings in a way so that we can also then reuse the resources in them in the future. And this is what I'm going to talk about now. Really what I want to show you is a bit behind the scenes of how we work with this, both in research and in practice. And we'll focus on these 6 key points that is the mantra that we apply to all of our projects, which is really about retain what makes sense, reuse materials where you can, and then recycle and upcycle the rest. Then when we design new buildings, that we design them for change, we design them for reuse and recoverability of materials, and then that we digitize materials will make all of this a lot easier in the future. So starting with retaining what makes sense. We normally use this little axis diagram to say that transformation can happen at lots of different scale. And we approach each project as unique cases. So at the bottom here, we have kind of the full conservation of projects, which stretches to a full new build project. The conservation is normally when we talk about the buildings that we love, that have a strong cultural value, a heritage that we want to preserve. But the reality is that we have a lot of buildings that we call are unloved. There are buildings that we might want to get rid of because they don't suit users' needs anymore, or they're not as attractive as they were when they were first designed. But they still hold a lot of value. So we work on this axis of looking at where can we find a balance between deconstruction and conservation and new build and conservation. And there's lots of different things that drives where buildings and projects land on this axis. It's everything from market attractiveness, the operational carbon, it might need an upgrade, the embodied carbon of keeping the materials, future resilience and adaptability of the building, the cultural and social value, and of course the cost and risk in the market. So how we approach this is that on every project we conduct we call it a forensic analysis. We go into the very detail of understanding the buildings that are there on site. So we have a little checklist looking through at actually understanding the existing building. We do this with a broad team. We do a 3D scan of the building. We look at the structural qualities. We dig holes to test the soil conditions and the pile conditions. We do an analysis of the lifespan of the different building components. And then from that, we look at, okay, this is our baseline. This is the building that we have at the moment. What are the options? What can we do with this if it's not longer attractive in the market? How can we change that? It can be by looking at different uses. It can be at looking at fully redeveloping the building. We also look at where is the value, and there's lots of different parts of this. It's of course also the social value and the monetary value, but one of the values we also look at is the carbon, the embodied carbon that is in the existing building. So we often do an analysis of where is the majority of that carbon and which parts of the buildings are really worth keeping to try to minimize the overall carbon. We then look at different options to try to realize those use case scenarios that we have identified, and it's a scale again, and developing lots of different scenarios that we can then analyze. And one of the important things is obviously that we compare these options across multiple different things. So again, if we talk about carbon, we do an analysis of the upfront carbon, which is the material-related carbon in those buildings when we would redevelop it. And often we see that, of course, the kind of light touch conservation is the one that would result in the least amount of upfront carbon. But sometimes what we also see is by doing that, the whole life carbon might actually be higher because in 10 years' time, we might still need to replace the whole facade to bring that building up to operational carbon. And this is why we think it's really important to look at it from a holistic perspective. And it's not only carbon, it's also all the other topics, but that would result in a 10-hour lecture, so I will not get into that, but very happy to discuss it afterwards. So we have a few projects that have been recently completed that fit very nicely into this diagram. And as you can see, some are very clear. An old police house in Denmark having a full internal renovation, but keeping that cultural value of it. A hotel in Greece that had an outdated kind of facade and market attractiveness simply needed a replacement of that facade and an upgrade to the interior, but the structural bones of that building were great, and they can last for another 60, 70, 100 years. An old also police school in Sweden that got transformed into a university building, also looking at where we can see opportunities of, for example, these incredible spaces that might not be necessarily still suitable as a pool, but can have other functions like a lecture hall or a library. And then we also work a lot with these, is probably what we called some of the unloved buildings. There in London in particularly, it's offices that have been built in the 70s and 80s. They have quite shallow floor-to-ceiling heights. So according to the office market at the moment, they don't see them as attractive. And these are buildings that should have a much longer lifespan still in them. And what we look at is how can we redevelop this into something new. And in this case, it had to become that we had to demolish the actual floor slabs to get a greater floor-to-ceiling height, but we could retain the entire core of the building and the substructure, which was about 40% of the embodied carbon of the existing building. And one of our key projects that have recently won a lot of awards, which is very exciting, is QQ Quarters in Sydney, which is taking this building in Sydney Harbour with fantastic views and a fantastic opportunity to become something completely else and a new tower that hopefully can stand for another 80 years or 100 or more. And what we managed to do here was actually to keep 68% of the existing structure. So we stripped off this red bit, kept this core, and then added a core to be able to double the size of the building. This was very much driven by local planning guidelines saying as well that if you did tear down the building, you wouldn't be allowed to build this high again. So it was a great incentive for the developer to say, okay, let's try to make as much use of the existing building as possible. So existing, cut it down, extended the core, and then added a new floor plate. This is a bit what it looks like in the pictures. Obviously a very complex process and required a lot of collaboration with very, very skillful engineers to make this happen. But the exciting thing is, hopefully this works, is that we could maintain 65% of the structure, 98% of the core. We doubled the floor size of the building, saved 130 million Australian dollars because we avoided demolition and materials of rebuilding that core. We saved about 9 to 12 months of the program of the building, so it could also be on the market much earlier, and about 12,500 tons of carbon. So it's a great way to show that reuse really can bring value. And it also brings value in terms of creating a new, very attractive office space in Sydney that hopefully will remain attractive for a very long time. When we cannot do this, when we can't keep the majority of materials, we look at, for example, the tower in London, where we only kept the core and the substructure. What do we do with the other materials? They can still be reused, even though they are not retained. So how we approach this is that on all projects we work on as well, we try to map the materials of the existing buildings, the quantity, the quality of them, and the value they might hold. And then we work with the waste hierarchy, which means that the higher up we can be here in terms of reusing or upcycling or recycling, we avoid value loss. And the further down, we definitely don't want to send materials to landfill. So we try to find solutions to keep them up on this scale. And always focusing on reuse first. So for all projects, we create what we call a material reuse and upcycling catalog, which maps the whole building and the potential of the materials in there. It again relies a lot on collaboration, because reuse is not only valuable if it happens on your site or in your building. Reusing of material is really being part of a wider urban ecosystem where material flows can happen across the city. So in London at the moment, we have 4 or 5 projects that have different reuse catalogs, which means that we can build a strong network of manufacturers, material producers who might be interested in these materials. And then what we do is we map it, and then we look at this would be the business as usual case in terms of the hierarchy of waste. Where would these materials go? Most often they go to recycling, more often they go to downcycling, which means that they actually lose the value they have or they get disposed of. With the catalogs that we develop, we look at what are the options to actually retain materials, how can we send them for reuse either on site or off site, and then how can we move them from downcycle to upcycle and from disposal to at least downcycling. So on the Euston Tower, we managed to move about 65% of the existing materials by volume up the waste hierarchy. And that we think is really successful because it saves carbon and it saves monetary value as well. When we look at how to approach these things, we normally target the materials that have the highest embodied carbon and that we also have the highest amounts of. The most common ones are always glass, aluminum, steel, and concrete. Steel has a pretty good reuse story already. It's a scarce resource. We do reuse it quite frequently. Glass and aluminum is more difficult, but they have good recycling cycles. Concrete is a really big issue. It's very difficult to recycle. It's very difficult to reuse. So it's one of the ones where we have gone very geeky and got into research on this. This is how concrete normally ends up. It becomes downcycled into aggregates that goes into roads, pavements, but it very rarely goes back into buildings. So through 2 research projects called Precast and Resource Blocken, they're both Danish research projects funded by the government, where the government at the moment is looking at demolishing about 32,000 apartments across Denmark, because they're social housing apartments that were built, the majority of them in the 70s and the 80s, and the government thinks it's time to revitalize them. It's incredibly wasteful in terms of the material value of those dwellings, but also the carbon that is related to them, because they are going to be replaced. So we're not demolishing them, we're actually replacing them. And what if we could actually reuse those materials instead? And that is what these research projects have been focused on. So it's looking at, can we take these buildings that are being demolished and look at them as material banks? Most of them are constructed in prefabricated concrete, so all elemental buildings, which should, you would think, make it easy to take those elements apart and maybe reuse them elsewhere. It's not as easy, but we had big ambitions. There were 5 different architecture firms who looked at how could we design new dwellings with the elements from these existing buildings. Having these great images of actually being able to reuse whole elements to build at least 30% of the new buildings. That means also looking into how do you get the concrete elements out. It needs quite significant intervention in terms of blade sawing them out from their positions, then trying to carefully lift them out. It's very difficult when you have these not very graceful machines to do that, and each element weighs about 3 tons. And then how do you then lift them from a place to another place without breaking them? It's a research project that's been going on for 4 years, and we're still at a point where it is very difficult to keep those elements in a good quality enough so they can actually be reused. And then all of the elements are tested. They're worked with structural engineers to see what different interventions, the impact it has on the structural quality of the elements once they've been taken out. So the short conclusion at the moment is that we cannot rebuild with those existing elements. The quality is not there. We don't have a process yet to actually be able to extract them in a way to make it feasible. But what we can do instead is look at maybe they can be resources for something else. Industrial warehouses don't require the same kind of safety guidance as residential buildings, so they are a great way to look at. We have a lot of resources. in terms of concrete elements. Maybe we can start building warehouses in Denmark with these elements instead. So we tested that with a client who is actually from a demolition contractor. They now call themselves a deconstruction contractor. And they wanted to build their new headquarters in an industrial warehouse with only found materials. So great opportunity. We managed to look at how we could take some of those prefabricated elements and actually build the interior for them using them. It's a very small scale, but this is how we work at GXN. We like testing things at small scales to prove the concept, and then we can push it into projects with the help of 3XN and test them on bigger projects. So that is also now what we're doing on the Euston Tower in London, where we are now investigating is also a prefabricated system in the existing tower. We know how much we have, and we are looking at can we design the new tower based on similar dimensions and potentially actually reuse some of those slabs in the new building. This is yet to be confirmed. They are taking out the first panels for testing in a month or so. So we will see. It's obviously groundbreaking. Most likely we will be stopped because of insurance issues or something, but it's great to see that we have developers and we have project teams on boards who want to test this. And as long as we can try to test it, we push industry slowly forward. Then upcycle and recycle the rest. If we can't reuse building elements, what we look at is keeping them at least in the upcycling or recycling routes. Glass is an excellent example. It's very difficult to reuse directly because it's very fragile, costs a lot to take it out very carefully. Recycling glass, especially building glass windows into new windows, would be a fantastic opportunity. Unfortunately, less than 1% of the glass recycling of windows in Europe actually becomes new windows. Mainly it becomes new glass bottles. So if we can't keep those, the recycling hierarchy, how can we then create a middle layer, which we call upcycling, where instead of sending glass to become glass wool or glass bottles, can we turn it into something else and make it an architectural element in the building? Sorry. So, 2 Finsbury Avenue is what we call an upcycled tower, almost. It's another tower in London that replaced existing building on the site from the 80s. It's actually 2 buildings. You can see the other one to the right in the image. That one has been fully retrofitted and refurbished into an office, but on this building site, the clients had the opportunity to build a tower to create new office area in London. So this started in 2016, and the decision was that it was very difficult to reuse the existing building. It would have to be demolished. But then we were looking again through our material catalog, what can we actually reuse from this building so that those materials don't go to waste. And we created part of this catalog. Of course, parts were sent for reuse. For example, the steel in the building, about 40% of that has actually been reclaimed and sent for reuse elsewhere in London. But there were a lot of other materials that were difficult to reuse. For example, the aluminium facade, the air duct types, so any building services are often go straight to landfill, and air duct vents. So we created a full catalog of what are the potential of actually turning these materials into, say, internal finishes. Because internal finishes often don't have the same requirements in terms of having an insurance and quality certifications. So we created a full catalog of different options. Some of them we see also that upcycling and recycling can bring another type of experience to a project. So as I mentioned in the beginning, GXN also focus a lot on behavioral design, which is about the user experience. And we think it's very interesting where we can use upcycled and reused materials to create that user experience by textures and colors that also reflects the past of the building. We also see it as a learning tool. If we can display upcycled or reused materials, maybe it can also help communicate to the wider public about the wasteful economy we're currently in, but the circular economy that we can be in. So in 2FA, what we have managed to do is actually take the aluminum facade, remanufacture it into the wall finishes for all of the lobby areas and the lift areas in the new building. It looks like a very smooth process. It was definitely not this smooth, but I think my colleague Henry Glugau would talk about a bit more about this process in a lecture tomorrow. But what it does is, of course, again, what we look at when we do this, aluminum is a highly recyclable product. It is very valuable when it gets fully recycled as well. So when we look at these opportunities, we also make sure that we don't waste any of that value of recycling the aluminum when we try to reuse it instead. But in 2FA, it showed that it was a good benefit for the project. We brought down the embodied carbon of the interior finishes by quite a lot by reusing the aluminum from the facades. And a short point I want to make on glass is just to encourage everyone to try to look at how we can recycle glass more. Because as I said, less than 1% of windows actually gets recycled into new windows. It's really wasteful, so we always use virgin materials when we produce new windows. And the reason for this is because the way that we laminate and coat glass makes it very difficult to try to recycle it and get the high-grade cullets that we need to be able to create new windows. But if we do take the time and we do really try to do this, there are significant savings, both in terms of the money when we in the future have more resource scarcity, but also in terms of trying to reduce carbon in the glass industry. So wherever you can, try to send glass for recycling. I hope I'm okay for time. But to talk a little bit about when we design new buildings. Obviously, what we want to do is try to reuse as much from the existing, but when we design new buildings, we also want to make sure that it's easy to reuse it in the future. And the first point of that is to design for change. So going back to these, the social housing blocks built around Denmark, they were once very loved buildings, very functional buildings. But today, unfortunately, they are not anymore, and that is why the government thinks they need a change. And we always go back to this quote from Stuart Brand at GXN, that all buildings are predictions, and all predictions are wrong. So we need to design for our predictions to be wrong, and for our buildings to be able to adapt and change in the future. So we don't want to see this happening again. We should never demolish 32,000 apartments to replace them with new apartments. We should build new apartments that can then be adapted and change typology for different types of family sizes as the needs changes. And we think it's very important to do that by looking at Stuart Brand's as well concept of designing for layers. So a building have different layers that all have different lifespans. And the reason they have different lifespans is because they're impacted by different types of change. With buildings are impacted by market change, climate change, regulation change, lots of things that will have different impacts on these layers. So we need to try to design each of these layers so that they can be replaced and changed independently. The same goes that these changes also impact different parts of the building. So either the space units and the types of space we need, the building components, the elements, down to the very materials. And as part of one of the research projects we're working, which is an EU-funded research project called Circuit, we're looking at how this applies. There's a spectrum of adaptability, we call it. So we can either work with multifunctionality, meaning nothing has to be disassembled, but a space is designed to be multifunctional. We can look at transformability, where parts of the space might be able to transform to host different needs, but the external stays the same. And then demountability, where everything can be taken apart and it helps replacement and maintenance. And just some core kind of ideas around this is about for multifunctionality, it's about designing in load capacities, massing, and circulation that suits different needs. For transformability, it's about looking at not having load-bearing partitions and not load-bearing facades, which might take down a whole structure if the facade needs to be replaced. And demountability is about reversible connections and accessible connections to make it easy to take things apart. But all of this comes at a cost. So we think that all project, again, is unique. Like we said, it's very difficult to predict the future. We can't. And all of these different approaches to designing for change does come with a carbon cost and material investment. So we need to try to think about what are the probable, plausible, and possible futures that we should be designing for. And one way we approached this was again at QQT in Sydney, where the idea was to create villages for office workers. And also thinking that the way we work in offices changed very dramatically, very quickly, as we've especially seen in the last 10, 20 years. So for QQT, the idea was to enable different type of tenants to be able to inhabit this building and for the building to suit their different needs. And then we were looking at creating these demountable floors, which would allow tenants to either span across 8 stories or to just stay within typical office floors. It also means that they could increase the circulation, they could bring materials in this way. So there's lots of different possible functions. So we did this by building in this demountable floor. And the whole idea there was for all of those floors to be fully disassembled from the rest of the structure and for you to be able to do this without actually taking off the facade of the building. So this means also thinking about how do you get those materials out from the tower. So designing each of those elements actually fit in a service core so that they can be removed from inside the building without having to add anything new. And this is what it looks like when it was constructed, and it now allows for that future adaptability, which hopefully will make this new tower or this extended life of the previous tower to be extended even further in the future. Then we look at design for reuse and recoverability, and this will be a short one, but it's more about looking at the materials, the lifespan, the standardization of connections and elements, and then the deconstruction possibilities of buildings. At 2 Finsbury Avenue, this was something we really wanted to investigate, to look at how do we avoid not learning anything from the past. So the reason why it was difficult to reuse a lot of the steel from the existing building was because it had a composite floor deck construction of concrete poured into a metal deck connected to a steel beam. And these little bolts here makes it very difficult to reuse the steel beams, because to get this concrete off, you have to pull off the concrete decking, which means that the steel beams gets bent. A lot of them ended up in skips like this. So when we looked at designing the new 2FA, we wanted to see a small intervention of just bringing in a separate steel plate that was then had 2 separate bolts connected, meant that we could actually lift out the whole metal deck without having to bend or pull on the steel beam. So keeping a lot more of the steel beams in the new building reusable in the future as well, hopefully meaning that the 2FA that is in construction right now can turn into something else in the future. And this is just a short video showing the testing of this connection and how that element can actually be lifted very easily without it being, perfect. So again, showing that it's great to work with clients and engineers that are interested at looking at these solutions, because this is a very simple intervention that adds a lot of reusability. And the last very thing is to map your materials. So when we do this reuse and upcycling catalogs, we rely so much on the data that is available on the buildings that we investigate. And we think that material passport and collecting information about the materials that we put into buildings now is really important to make the process much easier in the future. So we're starting to look at some key data that we think should be collected for all projects and then saved either in a digital model or even just in an Excel sheet to make it easier for someone in the future to look, what do we have, what is the quality of it, and what can we do with it? And that will enable us to create a fully circular system of materials where we can constantly recycle and reuse materials in a closed loop. So it brings us up to, back to our circular system with the key strategies. And the key things that I would like to share that I think is the important of making this happen is that we need to collaborate across disciplines. And we need to talk to people that we don't normally talk to, like the demolition contractors, way before we even start looking at demolishing a building. We need to allow time to actually invest in this, and we need to test and scale and always push for innovation on projects. And that was it. Thank you.